everyone. So today I'm going to go through practice exercise 10.4. So first question, question 14. So in the diagram, AB, okay, AB over here and AC, this long length over here, are tangents to the circle at T and S respectively. So then line, all right, and then tangent to the circle at P, line AC, tangent to the circle at S. Okay, so BQRC, this is a straight line. Okay, and PQ is parallel to SR. All right, so angle BAC equals to 80. So BAC over here equals to 80 degrees, and angle SRC over here, which is 102 degrees. So part A, find angle APS. So angle APS is over here. Okay, so for part A, right? So angle APS is actually, okay, so first thing first, triangle APS is an isosceles triangle. All right, how come? Because AP is the same length as AS because of tangent from external point are equal. All right, so maybe for a start, we can say that AP equals to AS, right? Because tangent from external point are equal. Okay, so therefore, angle APS, right, equals to 180 minus 80 degrees over 2, which is 50 degrees. So this is base angle of an isosceles triangle. Okay, so this is for part A. All right, part B. So find angle QPS. So QPS is over here, this angle over here. Okay, so first thing first, you need to realize that, QPSR is a cyclic quadrilateral, right? So it's contained within the circle. All right, so let's find out what is SRQ first, this angle here. Okay, so angle SRQ is equals to 180 degrees minus 102 degrees, which will give me 78 degrees. Okay, so this is a adjacent angle on a straight line. Okay, so this is 78. Oh yeah, let me just label, this is 50. Okay, so that means angle QPS is equals to 180 degrees minus 78 degrees, which will give me 102 degrees. All right, so this is actually what angles in the opposite segment, right? This and this is related. So angles in the opposite segment. Okay, so yes, this is 102 lah. Let me just erase this and write 102 over there. So this is 102. Okay, so the next part, part C over on the right. So part C, find angle PQS. So PQR. So this angle over here. Yeah, this angle over here. So as you can see, PQ, right? Oh, this is 78. PQ and SR is parallel, right? So that means I can say that angle PQR, right, and angle SRQ is they are interior angles. Or you can look at it another way lah. So PQ is parallel to SR, right? So you can say that SRC is equals to PQR, quite corresponding angle. Okay, so I can say angle PQR, right, equals to angle SRC, which is equals to 102 degrees. Okay, so this is corresponding angle, comma, PQ parallel to SR. Okay, so this is 102 as well. All right. Okay, so the last one, part D, angle ABC. So, okay, angle ABC. So angle AB, okay, so they want an angle over here, this one. Okay, this one, question mark. Yep. Okay, so for this, right, what you can do is I will actually try and find out uh what is angle ACR first, this one. Okay, I want to find out what is this first. So in order to know what is this, mm, I need to find out, okay, there's quite a few ways to do it lah. So I want to find out this, right? So I'll need this, okay, this one, all right, angle RSC, or if maybe I can, oh, okay, so this is, okay, yeah, so this is 50. Okay, this is 50 degrees. Why? Because as isosceles triangle, right? And then this one I also can find out, right? This one is actually because PQ and SR is parallel, so 180 minus 102, so this is 78 as well. Yeah. Okay, then after that I can find out this already. Okay, so never mind, let's write out together. So angle ASP equals to 50 degrees, right? Because this is base angle of an isosceles triangle. Okay, then after that, angle PSR, this one is 78. Why? Because 180 degrees minus 102 degrees equals to 78 degrees. So this is a interior angle, comma, PQ parallel to SR. Okay, so because this and this, so these two is interior angle. Okay, so lastly, angle RSC, right, equals to 180 degrees minus 50 degrees minus 78 degrees, which will give me 130 minus 78, which is 52 degrees. Okay, so this is 52 degrees. So that means angle, oh, okay, wait, before that, the property here is adjacent angle on a straight line. Okay, so 52. So next, angle SCR equals to 180 degrees minus 102 degrees minus 52 degrees. Okay, so 180 minus 102 minus 52, so that will give me 26 degrees. So this is 26 degrees. This is sum of angles in a triangle. Okay, so lastly, angle ABC, right, is equals to 180 degrees minus away 80, right? This angle BAC, 80 degrees, and then minus 26 degrees. So this will give me 74 degrees. So same reasoning lah. Sum of angles in a triangle. Okay, can? Yeah, so part A, part B, part C, and part D. All right, so this is it for question 14. Okay, let's do question 15 together. So in the diagram, Tn is a tangent to the circle. So Tn is a tangent to the circle, right, at N lah. Right, and then O is the center of the circle, and OPT is a straight line. Okay, and then they say that Tn over here is 12, and PT over here is 9. So part A, find the radius of a circle. So in short, right, they want us to find out what is ON lah, this length over here. All right, which is the radius. Okay, so actually from this, right, we can form an equation, right? What kind of equation? So part A, right, because, okay, so we can say let R be the radius lah. So let R be the radius of the circle. Okay, so that means this is R, correct? So I can say that R square plus R plus 9, no, R square plus 12 square equals to R plus 9 square. So I'm making use of Pythagoras theorem, right, to form an equation. So R square plus 144 equals to R square plus 18R plus 81. So 18R equals to 144 minus 81. I skip a few steps lah, huh? So 63. So R is equals to 63 divided by 18, which is 3.5. Okay, so 3.5 cm. All right, so R is 3.5 cm, and that's for part A. Okay, so next for part B, angle PON. So they want this angle. All right, so we are going to make use of, okay, because this is ON, right, is a radius, and NT is the tangent. So that means we can say that angle ONT equals to 90 degrees. All right, because tangent perpendicular to radius. So that means we also can tell that triangle ONT is a right angle triangle. All right, so that means we want to find out what is PON lah, right? This angle over here, right? So we can say that because okay, anyway, angle PON is equals to angle TON lah, right? It's the same thing. It's the same angle lah, essentially. So we can say that we can use Picasso actually because this is a right angle triangle, right? So opposite, so this is the angles in reference. So this is opposite, this is hypotenuse. So sine of, so sine angle TON equals to opposite 12 over hypotenuse, which is 9 plus 3.5. Okay, so angle TON equals to sine inverse 12 over 12.5. Okay, so that will give me 73.73979. Right, round off 1 dp, 73.7 degrees. Okay, so that's for part B. Okay, the last one, part C over on the left. Find the area of the shaded region. Okay, so basically this one you got to find out what the area of this right angle triangle minus the area of this sector. Okay, so that means, okay, let's find area of sector first. Okay, so area of sector PON, PON. Okay, so equals to theta, which is your 73.7397 out of 360 times pi times r square. Okay, so this will give me 7397. 7.88287. Okay, so area of triangle TON equals to half times base times the height, which is 3.5. So equals to 21. So lastly, shaded area equals to 21 minus 7.88287, which is 13.11713, round up 3SF, 13.1 centimeter square, 3SF. All right. Yes, so this is it for question 15. Okay, let's take a look at question 16. This is the last question that I'll be going through from exercise 10.4. Okay, so in the diagram, TA and TB are tangents to the circle with center O. So take note, TA is tangent to the circle at A, TB is tangent to the circle at B. So we know some circle property, right? So that means OA is a radius or center O lah, okay? So OA is the radius and AT is the tangent. So that means tangent perpendicular to radius. Tangent perpendicular to radius. Okay, that's the first thing. Second thing, right? We also know that TA, the length of TA is equals to length of TB. Why? Because tangent from the external points are equal. Okay, so that's the second thing we have to take note. So part A, right? How to find OTB, right? Okay, so maybe we have to write it out lah. So OAT, angle OAT, right? And is equals to angle OBT, which is 90 degrees. So this is tangent perpendicular to radius. Okay, the next one is AT equals to BT, right? Which is tangent from external point. Okay, they are equal. All right, so as you can see, right, that means we can say that angle OTB, right? So OTB is actually a right angle triangle lah. Okay, in short. So yeah, so this is 18. Okay, so yeah, so okay, so oh, wait, OTB, oh, because this is actually, if you draw a straight line over here, right, you realize that, right, triangle OTB and triangle OTA, they are congruent triangle. You can prove using SSS also. Yeah, so same radius, common length, and BT and AT are equal length. Yeah, so you can say that therefore, angle OTB, right, is equals to 50 divided by 2, which is 25 degrees. So that's for angle OTB. So angle AOB, right? So AOB is the big one over here. We can find AOT lah. So angle AOB is actually equals to 2 times of angle AOT. Okay, let me just write angle properly. Equals to 2 times. So angle AOT is just 180 minus 90 minus 25. So equals to 130 degrees. Okay, so 90 minus 25 is 65 lah. So 65 times 2, 130 degrees. Okay, so this is for part B. Yeah. Okay, last one, part C. Oh, I forgot to change the color. So part C, find the shaded uh region. So we can just use area of triangle minus the area of circle and then times 2. So area of triangle is just okay, let's take a look. So this is 25. Okay, we got to find out what is AT first lah. So tangent, right, Tokaso. So tangent 25 degrees equals to opposite over adjacent. So AT is equals to 18 divided by tangent 25, which will give me 38.6011. Okay, so AT is 36.8011. All right. Okay, so we know that angle AOT here is 65. Yeah. Okay, so yes, so let's find the shaded lah. Okay, we can find the one of the shaded first, this one. Okay, so continue on the left. So triangle, area of triangle OAT is equals to half times 18 times 36.8011, which will give me 331.2099. Okay, so then I want to find out the small sector first lah. So area of sector, okay, is equals to 65 over 360 times pi times r square. So this is, I'm going to leave it in pi first lah. So later when I calculate, it's easier. Okay, so shaded region. Okay, so take note for the total shaded region, right? I need to times 2 because I only found one part, but is the shaded region is the entire thing. So it's 2 times of 331.2099 minus 58.5 pi. Okay, so that will give me 331.2099 minus 58.5 pi. Pi. Okay, so I will have to Wait. Okay, sorry guys, I think I made a calculation error. So for the area of triangle OAT over here, right, it's not 331. All right, it should be 3, 4. Let me just write out in red. It should be 347.4099. So I should be using this. All right. So nothing wrong. Nothing wrong with other steps, just that I did a calculation error over here lah. Yeah. Okay, so let's recalculate this again. So 2 times 347.4099 minus 58.5 pi. Okay, so the answer, yes, it should be 327.253, round up, 3SF, 327 centimeter square. So 3SF. Okay, yeah, so just take note lah, just now the black, the font in black, just now I've written, right, there's a calculation error. So all these are the red font, which is the correct one lah. Okay, okay, yes, so this is it for question 16.